Dear students, today I'm going to finish this lesson 3, and then I will cover pages between 78 to 84. This is the last session for your lesson 3. The next time we will start for lesson 4. Today our topic is metal, alloys, and crystals. But first of all, we need to know about the four key definitions. The first one is giant metallic lattices. We studied before. We know what is the metallic connection, bond and ionic bond. We studied before, but this is the result of metallic bond after many thousands or million atoms of metal ion. When they connect to each other, they will create a very big or giant metallic lattices. And lattices of positive ion in a sea of electron, which we learned before. The positive ion, they can hold to each other. These forces is provided by mobility of electrons. The movement of the electron make like a glue to hold all positive ions next to each other. Giant ionic lattices, lattices of positive and negative ions. This is different rather than the last one. The last one is the electron, which hold the positive ions. Here we have two kind of ion, positive and negative. And because of the electrostatic forces, they can hold each other. They can hold each other in a big structure. And the next one is giant molecular lattices. In fact, this type of lattice or big structure is held by covalent bonding, like a diamond and graphite. So here, these lattices are very big, and it's called macromolecular. That is kind of very big structure, so it's called macromolecular. And we have another type of connection between the molecule, that is simple connection in molecular substance. They are not lattice, they are just form of substance, so they can held together by weak forces, like water, that the molecule can be to next to each other by very weak forces. First, metal crystal. The first point is, if the atoms are ions, if they pack to each other very closely, they will be very high density, very heavy. Or if they pack less closely, they have low density, like lithium or sodium. Lithium and sodium ions, they are not closely packed to each other, so they would be lighter metals, and as you can see on the picture, they will float on the water, so even they cannot drop in the water. Another point is, if you remember, for the structure of metallic lattices, we have layer, right? There is many layer in the lattices. In any lattices, we have very arranged ions, either in ionic form or atomic form, no different. They are well arranged and they make a layer form. So this layer can uh, move over the another layer, as you see at last picture. They can move, and this property we call malleable. So that make a flexible form of metal, and you can make many different shape like this pipe and metal sheets and many things. That's why we can form the metal, because in lattices each layer can move over the another layer. Also, metal crystal can be stretched. Like here, you can stretch the metal and make a wire. So this property is ductile. We say ductile, that you can stretch, you can pull the metal and make a wire. And then other things, some of them, not all, that they have a very arranged structure, arranged position. Some of them have irregular crystalline structure which can be observed under microscope. If you see those kind of metallic lattices under the microscope, you can see this shape, this kind of shape. This is exactly come from the microscope pictures, and there is an irregular crystal area for each piece. We called grains. Okay, so each picture has many grains, and these grains can be connected to each other. Not connected, they are separated to each other by grain boundaries. There is a border between them, and for this one, this line we call grain boundaries. Also, you can see in the real pictures there is a grain boundaries between very small piece of metal, and the smaller grain size is stronger and harder piece, and they break down harder than the others. So here you can see we have some smaller size grain. They are stronger and harder. Alloys is mixing of the metal to get better properties rather than pure metal. So these are important to learn: brass, bronze, mild steel, and the others. Okay, this type of alloys, and you should know each alloys is consists of which type of metal. The percentage are not very important, but the type of metal which create the alloys is important, and also the particular application, the which application and the properties also, these are important. You should keep in your mind. And we mix metal to get better properties, because to reach better function. Based on the situation, a condition that we need that those alloys, uh, either we need to get harder alloys, or softer. Maybe we need lighter, something for plane, aircraft, something like that. Or maybe based on the condition, we need heavier alloys, like for construction, to make a very stronger building. So we need heavier. And for better electric conductivity, to transfer the electricity faster and with higher quality. And the next one is ionic crystals. Is actual arrangement of ionic crystal. It depends on the number and the ion size. We cannot say that every kind of ion can be hold to each other and make a ionic crystal. No, it depends that two kind of positive and negative ion, they should almost have a similar size, and the number also. The number we need to know. For example, a positive ion can receive how many negative ions, which is out of this discussion, and maybe we will talk about later about the unit cell. This is kind of, we say unit cell. And so the number and size are important for ionic crystal, and they are electrically neutral because we have the same number of a positive and negative ion. So all of these, for example, when they create a crystal, at the end they are electrically neutral. And ionic crystal is harder than a metallic crystal, which we talked about before, and but it's easier to break down. For example, yeah, we can break down easier than metallic crystal. And another thing is in metallic crystal, ions are held by mobile electrons that I explained you before, but in this case here, electrostatic forces between positive and negative ions, they can hold each other, they can take a position together. And this is a comparison between metallic crystals here, which there is a mobile electron between the positive ion, and they can keep the structure. And this is a sample of ionic crystal. Okay. And ionic crystal in water. Ionic crystal can be dissolved in water, and after they dissolve, ions in solution can separate it. Here there is an example of salt, sodium chloride, and when they go to the water, and ion can be separated to chloride and chlorine negative ion, and also the sodium positive ion. And as we know that the water molecule is a polar, and it has different polarity. In the hydrogen side, we have positive charge, and for the oxygen we have a negative charge. So here we have a positive ion like sodium. Sodium can be surrounded by the oxygen side of water, which has a negative charge. So negative charge can cover the positive ion. And another one, chloride ion, negative form, can be surrounded by the positive side of water, which is hydrogen. So the negative ion can be surrounded by positive side of water, which is hydrogen, and the positive ion can be surrounded by a negative side of water, which is oxygen. And this can make the solution move around and carry the electric current, okay? Because this positive and negative can move in the solution and they can carry electric current. About the giant molecular crystal or macromolecular structure, you need to have a self-study. There is not important point, except you need to learn the differences between diamond and graphite. These are two important material from the macromolecule. We have a lot of macromolecule, but diamonds and graphite are the most important example. And so don't forget to study and read carefully the pages between 83 and 84. These two pages just is text and you need to read. And these are question 1 and question 2 and question 3 and question 4. Okay, these are your question and you need to give me the answer. Thank you so much. This is the last session of lesson 3.